Hello good people, I'm going to talk about solubility of common ionic compounds in water. In chemistry, it is very handy to know which ionic compounds or salts can be dissolved in water. However, as there are many ionic compounds, it would be a bit hard to remember them all and their solubilities. Luckily, there are two tables that can help us with this. This is a table of ionic compounds that are soluble in water. How do I use this table? To start with, the table is telling me that compounds that contain nitrate are all soluble in water. So, for example, if I write it down here, sodium nitrate contains nitrate and is therefore soluble in water. Or maybe ammonium nitrate. Again, it contains nitrate and is therefore soluble in water as well. What about compounds that contain chloride, bromide, and iodide? Well, the table is telling me that all compounds containing these three anions are soluble in water unless they happen to be paired up with silver, lead, and mercury. And so magnesium bromide is soluble in water, whereas silver bromide is not, because it contains the silver cation. In a similar fashion, all compounds containing the sulfate anion are soluble in water unless that sulfate is paired up with either barium, lead, mercury, or strontium. And so I could say that sodium sulfate is soluble in water, but barium sulfate is not soluble in water. Now let me bring in the second table. The second table is giving me compounds insoluble in water. In other words, now I'm looking at salts that will not dissolve in water. How does this table work? Well, it is similar to the previous one. Now I could say that all compounds containing carbonate or phosphate are insoluble in water unless they are paired up with group 1 cations or the ammonium cation. And so, for example, lithium carbonate is soluble in water because the carbonate is combined with a group 1 cation, lithium. On the other hand, if I have magnesium carbonate, it is not soluble in water. A similar situation arises with sulfide and hydroxide anions. Most salts containing these two anions are not soluble in water, unless the cation is a group 1 cation or calcium, barium, strontium, or ammonium. And so I could say that sodium sulfide is soluble in water because I have combined the sulfide with a group 1 cation, sodium, but magnesium sulfide is not soluble in water. In a similar fashion, sodium hydroxide is soluble in water because I have combined the hydroxide with a metal from group 1, sodium again, whereas magnesium hydroxide is not soluble in water. Note that these two tables do not encompass all of the possible anions and cations, but they do include some of the more common combinations, and thus they can be used to predict whether a salt will be soluble or insoluble in water. Before I finish this video, based on these two tables, would you expect calcium carbonate to be soluble or insoluble in water? If I look at my second table, here's the carbonate, and it's telling me that most carbonates are insoluble in water unless they are paired up with group 1 cations and ammonium. Calcium is in group 2, so calcium carbonate would be insoluble in water. That is all for now, and I will see you on the flip side.